Welcome back. In the previous video, we cover the topics of logistic regression. We went through the basic concepts of logistic regression, how it can be used in classification-based machine learning problem, and we went on to develop an algorithm using logistic regression to learn from the data and also make prediction with it. We also did an exercise. I gave you an exercise called dataset 2 for you to try that out and just to compare the predictions of the logistic regressions versus the reality of it. We also, of course, made use of the scikit-learn library to perform the modeling or training of our logistic regression algorithm so that it generates the coefficient to help us for the prediction exercise. So in this segment, before we go into a little bit more depth, I'm going to cover scikit-learn definitions of what supervised learning is, just so that we know where we've been so far. We've covered regression in the previous segment. We're going into a little bit more depth now in classification. We touched on that a little bit in logistic regression. We're going to go into that a little bit more in depth. In this segment, we are going to focus on binary classification, which is either 0 or 1, true or false. Basically, it's a yes or no, on and off kind of, what do you call it, on and off kind of so-called problem. In particular, we're going to make use of the MINTS dataset. The MINTS dataset is a set of 70,000 small images of digits hand-drawn. These are handwriting of digits, meaning 0 to 9. There's a little bit more descriptions of this via this link, but for now, we're going to go into that and a little bit more in depth. Now, first and foremost, just so that we start off on the same basis, remember in previous tutorial we did mention that classification is under the supervised learning. It belongs, sometimes your samples belong to 2 or more classes, and we want to learn from already labeled data how to predict the class of unlabeled data. Now, the class of unlabeled data basically means that we have new data sets that we haven't labeled what they are yet. So an example of classification problem would be the handwritten digit recognition example, which is the problem that we're going to tackle. In this example, the aim is to assign each input vector to one of a finite number of discrete categories. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Another way to think of classification is as a discrete, as opposed to continuous form of supervised learning, where one has a limited number of categories, and for each of the n samples provided. And what you're trying to do is label them with the correct category or class. We've already touched on regression, so I won't dwell on that now. So to begin with, I want to actually point you to the MINTS database. This is the famous database whereby there are 70,000 small images of handwritten digits, and you can actually go through these step by step, and it's been applied to many or I should say many classifiers has been used to apply to it. So you can actually see that there's ANN, there's KNN, and there's also support vector machine, so on and on it goes. So it pays to actually start with these basics so that we can actually move on further from here. Now, first of all, we need to actually get our hand on the MINTS database. How do we actually get a hold of that? The beauty is that scikit-learn has this functions whereby you can just import it directly into your notebook. You can just use this function called fetch_ml data and then instantiate it and so import the so-called library, and then download the MINTS original and store it into the MINTS variable. So what does the MINTS variable looks like? It's stored in this format. You have the label, you have the data, you have the descriptors, as well as the data and also the target. The data here basically being our feature, which is the independent variable. Target is really what we are trying to predict. Okay, so keep that in mind. Okay, so what is not shown here, although it was highlighted earlier, there are 70,000. So we're just going to have a look at the length of the mints data. Okay, so 70,000 indeed. Okay, so a couple of things before we start digging into it. Remember, in the machine learning project checklist that we talked about earlier, there are a few steps that you do want to actually abide by and follow. The first thing is to understand your actual data itself. Okay, so visualization. And what we're gonna do is just store the mints data. Okay, so remember this is the independent variable, and we're gonna store the dependent variable, which is the actual digits itself, into y. Okay, so what does x look like? A whole lot of digits because it's an image. And what does y looks like? This is what y looks like. So if we let's just say have a look at x at the what does the x300 looks like? This is actually what it looks like. Okay, so a bit hard to actually decipher what it really means. So if you look at the corresponding target, it is actually a 0. So let's just say if we can put a 301 and see what it looks like. 301 is also 0. Okay, let's just say 310. Can't be so lucky every one of them is 0. Oh man. Okay, let's just say we go to, yeah, maybe it's actually 6,000. Okay, let's just try 60,000 actually. Are you kidding me? Okay, maybe the 70,000. Okay, 69999. Yay, we finally found a 9, a non-zero. Okay, there you go. This is what the looks like for the 70,000, the last one. So it's actually a 9. So let's look at the X shape. We have 70,000 rows of these, and then the actual what is made up of is 784 pixel. Okay, so let's look at Y, shape of Y. It's also 70,000, so as it should be. Okay, let's do some plotting. And I do want to have a look at what the 1000. So what I'm doing here is that I am storing the 1000 x into this variable. I just use underscore because I'm not going to keep it. The underscore image, I want to reshape it as 28 by 28. 28 by 28 is actually 784. So it's actually a square matrix. And I want to use the matplotlib image show and plot the actual image itself. As you can see, it is actually a 0. So if we go and plot the 6999, this is actually a 9 that we worked on and pulled out earlier. So let's just stick to the 0. Okay, and that's what we are working on. And if we look up the actual target variable, indeed it is actually a 0. So let's understand the problem that we have here is that we've been given images and we're basically converting the images to pixels. So the pixel is 28 by 28, and we are trying to use these features and to train a machine learning model to identify from any future pictures that we give them what variable it is, between what figure, or between 0 and 9, which one of those digits it is. So that's really the actual problem that we have been given. In the next video, we're gonna move into the first step, which is splitting the data into training as well as test set, and keep the test set aside for future use. In the meantime, we're going to work with the training set that we have to develop a model to perform our prediction. Before we move on to the next segment, I'd like to give you a basic exercise for you to actually try out. The first and foremost, in terms of the exercise, I'd like you to locate the number 4 and plot the image itself. So let's take a moment, pause the video, and when you come back, I'll show you how I actually get the number 4 as well as plot the image itself. I'll see you when you come back. Welcome back. I hope you gave that a try, and might have some difficulties in some part. So let me just show you how I would do it. So we have, first of all, we just need to identify the type A. Type A is the actual so-called image that we're looking at. So we have the Y is this basically the storing the digits, and our X is actually the image or the pixels. So what if I want Y is equal to 4? This is how you do it. So you actually get a true, true, false, false, and all of the so-called whether it's a 4 or not. So with NumPy, it actually does give you this really neat function called where Y is equal to 4. And when I run that, well, it pays to actually import NumPy. Let me see. I don't think I've imported NumPy. So let's just put it in here. Import NumPy as NumPy. Okay, so let's just come back down here and run that. Notice that it gives you the actual index number that actually have Y is equal to 4. So let's just try that to see if that is indeed true. 24754. And yes, it is. Okay, so the next thing now is how do you actually plot the image? Recall that we did this exercise earlier. We can actually, well, copy and paste the code if we want to. So I'll just walk through this with you, just so that you can actually remember this. So X is where the storage of the images are. So we want the index 24754 being the where the location of the number 4 is stored. Y is the digits. The X is actually the storage of the so-called handwritten image itself. So the next thing we want to do is the image is equal to the value, reshape, and we want to reshape it to 28 by 28. And finally, we just want to plot that and the image. And it gives us a number 4. It's tagged as number 4, though it doesn't look like number 4. It is number 4. It vaguely looks like a 9 with the head chopped off, but ultimately it is actually a 4. So I hope that you found this exercise handy to consolidate what you've learned so far. The next portion, we are going to go into training a binary classifier. So I look forward to seeing you in the next video.